Welcome to this video. I am HasPhysics and today we are going to be going over accuracy and precision as well as systematic and random errors and how they relate to each other. First of all, we are going to be looking at what is the difference between accuracy and precision. So accuracy means how close your value or result is to its true value, and precision means how close together your values are after appearing in an experiment. So we're going to be going over an example exam style question which says explain how targets A, B, C and D represent different degrees of accuracy and precision. So as this is a 4 marker, we need to say what it means to have a high precision and a high accuracy. So a high precision means a low spread and high accuracy means close to its true value. So now we need to be talking about the targets. So target A has a high precision but a low accuracy, as all the points are close together but far away from the center of the target. B has a high accuracy and precision, as all the points are close together and they are close to the center of the target. C has a low accuracy and precision, as all the points are far away from each other and far away from the center of the target. And D has a low precision but a high accuracy, as all the points are quite far away from each other. And if you were to calculate the mean of the points, then it would be the center of the target. So for this question, you would only need to write 2 of these points to get the 4 marks, as well as the definitions. So extra definitions you need to know. True value means the value that should have been obtained from the experiment if no errors have taken place. Valid relates to how appropriate the experimental method is in addressing the aim of the experiment. Repeatability means how similar results are when a different person carries out the experiment with the same method. Reproducibility means how similar results are when a different person carries out the experiment with a different method. So now we are going to be going over the second portion of the video, which is systematic and random errors. So random error is caused by unpredictable changes in the procedure or experiment, and systematic error is caused by incorrect techniques or calibration of apparatus. So important note to know. There is a way of telling if your experiment contains a random and systematic error. If the values are close together but far away from the true value, high precision, low accuracy, then there is a systematic error. If the values are far away from each other but close to the true value when the mean is taken, low precision and a high accuracy, then there is a random error. If the values are far away from each other and far away from the true value, a low precision and a low accuracy, then there is random and systematic error. So how to increase precision and accuracy as well as reduce random and systematic errors? So the first way in doing so is repeat the measurement or experiment and calculate a mean to reduce the effect of random error. The second way in doing so is try to conduct the experiment when all the conditions are the same, like temperature and pressure. And the third way in doing so is using an instrument that has been zeroed and has a high resolution. A high resolution will reduce the percentage uncertainty. So now we are going to be going over more example exam style questions. So describe the procedure she should follow to determine an accurate value for the external diameter of the tube. So she should take measurements in different positions and orientations of the tube. As you go along the tube, you won't know whether the diameter of the tube will stay the same, and in different positions, it might have a different external diameter as well. And when you find them both, or if you were to repeat it more times, you will need to calculate the mean of the measurements, as this will reduce the effect of random error. So another example exam style question. So this question is talking about a pendulum that oscillates with simple harmonic motion, and a student tries to check the accuracy of the period t of the metronome using a stopwatch, and the student timed the pendulum as it moved from one extreme of the oscillation to another. So for this question, the question is explain how the procedure used by the student to determine t could have been improved. So first of all, you would need to time a number of oscillations and divide that time by the number of oscillations to determine the time of one individual oscillation. So the student in this question only timed one oscillation, which means that the effect of his reaction time from using the stopwatch will have a massive influence on the time measured, as the time period will be relatively short. But if you were to time multiple oscillations, then the effect of his reaction time will have a lower effect on the time measured. So yeah, so that's the second point here. So use a fiducial marker to identify the midpoint of the oscillation and time from that point. So if you put a fiducial marker to identify the midpoint, you'll be able to clearly see when the pendulum moves past it, and it will be also easy to tell, as that is where the pendulum will be moving the quickest. So it'll be easier to measure the time. And these methods will both reduce percentage uncertainty for t. And that is the question. So an important exam tip is if you get a question along the lines of state the purpose of calculating a mean, then you will always need to say to reduce the effect of random error. And thank you for watching this video. I hope you have learned something, and it would be really appreciated if you could share this video and subscribe. Have a fantastic day.